to Diane and David for giving me the opportunity to speak, get on my soapbox, and push the detail to you guys. So I'm going to start by just posting information to the chat about where the repo is, the demo, if you guys want to play with it. Now, this is a tool I've been working on for a little over a year now. I worked at a hedge fund in Boston for about 6 years. We did a conversion from SAS to Python. And so a lot of data scientists, a lot of portfolio managers, they've really wanted to be able to view their data in an easy way. SAS came with something like that right out of the box. So just bringing up big, large grids of data. Switching over to Python and mainly pandas, there wasn't something like that out of the box. So I had to try and build something. And so without further ado, let me share my screen. This is the repo here on GitHub. I posted the link in the chat. Nice little icon here. But to start, I'm just going to show a real simple example here. Just a small data frame. You import detail and you pass it to the show function. Why is it taking so long? Okay. Did I cloud my, well, you know what? This is why we have demo sites set up. Usually it doesn't work that bad. But anyway, if you were to pass your data frame to it, it should pop up with this large grid right underneath your cell in Jupyter Hub. Eventually, I'll probably try and restart Jupyter Hub in the background and see if that fixes it. It's been sitting open for about an hour and a half. But anyway, you're presented with a nice grid of data here. This is some housing data that someone gave me because they found a bug and they wanted me to fix something with it. You get all your standard functions, sorting, moving columns around. I recently built in column filtering. So this is a date column. We'll just filter it down to 1 day. And there you go. It shows you a nice little query language filter up here. You can drop the filter. It goes right back down. Gives you information about the size of your data frame. But the next nice feature is that it gives you information about all your columns here. You can click, scroll through each one, see information about the data type, little descriptive characteristics. So under the hood, this is just calling all sorts of different pandas features. If you want to see the code that's running this stuff or generating this stuff, you can click on these nice little code export buttons. It'll give you a little pop-up with some hopefully not poorly written code on my part, but I'll let you guys be the judge of that. And you can do some quick analyzations, gives you value counts. If you want to do ordinals with other columns, you can do that. It's been so long since I've added these features, I can't really speak to what the actual value is to this one here, but some people really like it. The other nice one here is the histogram. You get outlier detection with some custom functions, and you can apply the outlier filter to your data. The other nice piece is that any of these operations that you're performing on your data, filters and whatnot, or say building a column, so we'll just take square foot living, square foot above, and we'll just sum them. It gives you a little hint of the code that's going to be run. You create it. Oh, I need to put a new name. Yeah. And now if I scroll over to the far right, you will see this little temp column here. You know what? And of course, my fork me on GitHub icon is blocking that. You will not get that when you download this yourself and use it. So don't worry about that. But since we just added a new column, you will see that code be populated in the main code export here. So no, you're not going to see that. Well, you did. These are the issues with live demos. But the next nice feature, and I will jump over to a different instance here. I have multiple running at once. Test data. So the idea is that you can pass multiple data frames into detail and it will open up multiple instances for you. You can toggle back and forth. You can assign names to them, whatnot. Um, but a really powerful one is the correlations feature. And so this is literally just taking each column, correlating it against itself, giving some different shading based on how correlated it is or not correlated. By clicking on one of these cells, here we'll do column 0 versus column 1. And there is a date column present in this data. I'll jump over and show you. There you go. And if it sees multiple records for each date, it's going to give you this time series breakdown. So it's just going to take the group of values for each date and correlate it against a group of values for the date of the other column. And this kind of gives you the over time comparison. You click on one of these points, scroll down in the pop-up window, and it shows you the points that went into that day. I do have some other data that doesn't have multiple points on each day. So you can see here there's only one day and it has 1 point to it, but you still want to be able to do some sort of correlation against it, and that's where this rolling window comes in. So say you want to do like a 10-day rolling correlation against this stuff. Each one of these points will take 10 days worth of data and correlate it against the previous 10 days of the other column. So really powerful stuff. Once again, you know, code exports for all this stuff. Let me jump back to that instance. So the next thing I wanted to show, a nice little cool thing here, you can do certain types of little shading and automatic stuff. Like I got this heat map built in here. This is the by column heat map where each column is kind of self-contained by figuring out the color, the shading of each cell. So it's just like the maximum will get green, the minimum will get red. And then you can toggle between whether you want it overall. Obviously, we have some very large integers, so everything comes up red on the other side. But you can see what type, different shading for data types and stuff. You hover over the header, eventually it'll pop up, it'll show you the data type. Any missing values, there's a NaN right there. It'll also give a little icon in each column saying that you have missings in this column, outlier information, and the next thing I wanted to show is the charts. All right. So under the hood, this is using Plotly Dash. Plotly Dash is very, very powerful. Originally, I was developing all these on my own using React. I'm a full stack web developer. If you look at the repo, it's about a 50-50 split of Python and React or JavaScript. But it became just way too unwieldy for me to manage all these different ways to build charts. And I found Plotly Dash, and it's awesome, man. They have all these charts right out of the box. It's a little clunky to set up workflows, but you know, it is what it is. So just simple line charts here. There's no aggregation on this, so it looks a little bit weird. To show you the data again, this is like, you know, working at a hedge fund, you're usually dealing with universes of securities daily. So these are just some junk security IDs for each day. But anyway, the chart's going to look a little weird because it has multiple data points for each day on your x-axis. You can apply an aggregation here. Want to see the means? This is all BS data, so none of this means anything. It's more just to show you what it looks like. You can toggle between the bar chart, scatter. Pie chart's going to look a little bit weird because it has so many data points, but that's where you can just enter in a filter here and I'll lower it down a little bit. You can see some negative numbers popping up here. Obviously, you can't really represent negatives in a pie chart, so it just kind of highlights them here. For some reason, you're passing that. I do have a custom component that I built on my own, a word cloud, and there you go. It just kind of, based off the values, it'll bring them up bigger and bigger. Dash doesn't have a word cloud component, so I kind of had to build my own. I keep meaning to create my own Dash component with this. I just haven't gotten around to it yet. Not a lot of people are clamoring for word clouds out there, but it's cool. Heat maps. So you jump over to this, you're going to need 3 dimensions, obviously, your X, Y, and Z. So we go with date, and here's what we'll show the security based, and we'll just choose one of our numeric columns. And there you go. Give you some colors and toggle between the coloring of this stuff. The other nice feature is that if you want to take these charts on the go, you can click this little export chart button and it will export it to an HTML file for you. So you can just link it into emails and things like that, and you will get all the nice little zoom functionality and things out of the box. that Plotly gives you. Do 3D scatter charts, really nice. Surface charts, nice rocky terrain. Once again, the code export is here, and I've recently added the code for the Plotly charts. So say you wanted to generate a chart here and start building more enhancements on your own that isn't in detail, take the code with you, plop it into your Jupyter notebook, and you're off and running. This is supported in Google Colab and Kaggle and things like that. Kaggle's a little bit hacky. I'm using ngrok under the hood, so you get kind of limited on how many calls you can fire off. But Colab, I managed to find a way using their client-side proxy library to kind of be able to tie into your Colab instance and not be limited. Last one here, maps. So I have another data set based off of everybody's favorite coronavirus data. So this is just pulling some. I have the code if anybody wants it over here. It's just loading stuff directly from New York Times on coronavirus data. So if you just load this each day, it'll refresh for you. But anyway, we can build. Because this has state codes in it or state names, you can build choropleth maps off of this stuff. So you set your location mode. We'll go with US states. Gives you a little hint on like what they're supposed to look like. So these 2-character codes, locations, state code, value. We'll do cases, and we will do, where's my maximum? So the reason why I had to select maximum there is because if you go back here, there's multiple days worth of data, and the max, obviously, this is cumulative data, so the maximum is going to be the most recent day. I could have filtered it down to the most recent day in this query filter here if you wanted. And underneath the hood, that's just using Pandas query language. Has a little link to it in here if you want to get a little tutorial on how to use it, but it's pretty powerful stuff. Anyway, back to the chart, little red shading. Obviously, New York is still up there. California's kind of caught up. But if you don't want to do this maximum, you want to actually show an animation, we can animate by day. I probably should have filtered it down to the specific. You scroll down to the bottom here. I'm going to put a filter on this because from January till March, nothing really changes that much. It's kind of boring. You just hit the play button and you'll start. See, it's slowly changing here, and over time you should start seeing, it might be like mid-March is when New York really starts to kind of, it's slowly getting, yeah, there you go. You can kind of click along and restart it, sorry. But yeah, really, you can do a whole bunch of stuff with this. I mean, the column building things alone, I've recently been adding more kind of, more stuff related to what we used to do at the hedge fund here with like Windsorization, Z-score normalization, transforms. Transforms is huge because a lot of times we'd like to mean adjust data to kind of smooth things out, and you can do all that sort of stuff here. But yeah, that's a really high level view of all the functionality. If anybody wants or has any questions on what's going on underneath the hood, more than happy to answer them now.
You did have a question in chat from Ashish Gupta, who asks, are you using any methods for increasing the speed or speed of processing and generating visualizations?
So definitely in the correlations piece, I do a check to see if you don't have any missing data, and if you don't, then it goes on. It uses a function from NumPy for running the correlations that is like a bazillion times faster, because Pandas is doing all this like NaN handling that you don't need at that point. So a lot of people were coming up with like huge covariance matrices, and you try to run the correlations on that just using pure Pandas like core functions, and it's, we're talking minutes, and then you pass it to this NumPy function and you're down to seconds. But other than that, you can really easily hose your Jupyter notebook with this, because it is making like duplicating memory on on your, so like if you have your data frame in a variable before you've passed it into detail, it's going to essentially duplicate the memory there. We do offer different ways to manage the global state in detail. So if you wanted to like use Redis or something like that, we do have support for that. That also kind of comes in handy if you did want to support like a global instance of detail that where you had an interesting piece of data that you wanted people to be able to like play with. You can do it that way and have like a G-Unicorn wrapper on this thing that would spin up multiple instances and can handle the tons of requests. I really wish I could get my notebook working. Let me try killing this thing, because then I can really show you underneath the hood, like popping out the data and doing like static charts. Okay. There we go. So I have some of the functions here that were populating that data that I was showing you on the demo. So this just, you know, detail.show, passing the function, and it just displays it right in your Jupyter notebook. I really don't understand why it didn't work that first time, but you can pop it right out into your tab here, and that way you'll get the full browser, because you know Jupyter kind of limits you on your size. You can change the size of the cells. I've offered functions on how to do that. I don't remember them off the top of my head. That was one of the early features. But underneath, I think I have, this is the coronavirus one. Let's start off one more time. So there you go, it loaded your data right in. But when I exported that chart, underneath the hood, it's calling this like offline chart mode. You can do that in your Jupyter notebook. So that way, if you wanted to save this off and commit it to a repo so people can view the output on Jupyter Hub, you can. This is just under the hood, grabbing the maximum deaths, so the most recent. You could also do this by filtering it down to the most recent date, and you don't have to do max at that point. But now, like I was saying, if you save this down and you came back to it at a later time, it will still be there. It will still have the JavaScript functionality in it. So, yeah.
That's very cool. Like that's super powerful.
Yeah, I mean, there's other competitors out there, but they cost money. This is free. You know, this is just kind of a side project for me. I mean, with the pandemic going on, I have a lot more time on my hands. So it's fun. It's fun, and I really enjoy, you know, like people requesting new features. More than happy to add them, or any suggestions on how to do things better. Like you look at the code exports and you're saying like, wow, you're doing something terrible here. Please change this. More than happy to do that.
Pretty awesome. Thanks for making it free.
Oh no, I'd been working for so long, just things strictly for work. It was great when a problem small enough came along, and I was like, you know what? Like somebody was like, you should really open source this, and I was like, I've never done that before, and this was it. And it's still like, you know, you can keep adding more and more to this stuff.
Yeah. Yeah. So did this come out of your previous work at a hedge fund, or is it sort of like a totally separate project, but like the hedge fund wanted something similar?
So like I said, we did a conversion from SAS to Python. I don't know if any of you guys have messed with SAS before. It was kind of like the precursor to R. And they really wanted to kind of get with the times. They had done enough bastardization of SAS that they were like, all right, we got to move forward. We've been doing this for 20 something years. We switched to Python. And so, you know, a lot of these people are still in the SAS world. They don't know a lot of Python. So they needed a kind of easy client to mess with these pandas data frames and to use until they get up to speed, where they're like typing out commands on the fly and things like that. So the toughest problem was trying to replicate this ability to just bring up a ton of data all at once. So like millions of rows and things like that. And the difference with SAS is that that's all working off a file system. And so you've got a lot more power for how much stuff. I mean, still, if you're going to bring up a ton, like gigabytes worth of data, you're going to be waiting a while until it came up, even in SAS. But that's where the idea for like the web browser came up, and being able to just have a data frame in global state, so that in your Jupyter notebook, like if you wanted to make edits and things like that, it'll get persisted to the global state and shown up on the browser. Like and the other thing is just the browser will give you the illusion that you're looking at millions of rows all at once because you see the little numbers in the upper left. But in actuality, the packages that I'm using on the front end, React Virtualized, are very efficient, super, super well engineered. And it's only rendering what you see, what you can fit into your browser. And so like scrolling around and all that, it's just, it's pretty quick. I mean, this only has 7,300, but I think one of the other ones has more like, and that only has 98. I thought I had one to 10,000, or not 10,000, million, but maybe not. That, I mean, the initial test was against 2 million rows and 100 columns. That was like the initial like proof of concept, is that it had to work with that. The one thing that I have noticed is that if you do throw like a ton of columns at it, that's where kind of React Virtualized starts to fall over. But the row, you can throw as much at, it's more like limits you on how much memory you have on the machine you're working on. But yeah.
Well, that was awesome. Are there any other questions? Oh, we just got a question in the chat. Duncan Haywood asks, when one edits the data in detail, does it edit the data in the original data frame?
So it will edit the data that's part of detail, and you can pull that data out. So if you see here, I called detail.show and stored it in a variable, and then just pass the variable at the end of the cell, and that's what will trigger the initial rendering. But if I want to see my data, you can just grab the data property on your variable, and there you go. So if I had added a column here, like, let's see if I have enough room to work with. Oh yeah, it pops it up into a new window here. Temp, all 0, all 1. No, I think it has an issue with trying to trigger back to the parent window over here when it's in a notebook like that. But if I do data head, there you go. Your temp column is right there. So it will persist it back into your state, but it won't alter the variable that you initially passed into it. If you're just passing your data into it like I did here, there is no variable beforehand. But yeah, that way, like if you are doing like messing around and doing like testing out like some normalization or mean adjusting some data, you can spit it out afterwards, or you can always try and export it to a CSV or a TSV file. Use it later that way. I don't know why I can't see the chat while I'm like sharing my screen. Can't get at the.
No, that is a downside, unfortunately, that you can't see the chat while you're sharing.
Huh. Okay.